Good morning, sixth grade. Today we're going to continue talking about how rocks form and how energy affects different types of rocks. And we're actually going to learn a couple new vocab words that might help us understand how a third type of rock can form, because so far we've mostly talked about sedimentary and igneous rock. So we are going to start off with this email from Dr. Jackie Lewis, the professor of geology that we saw in our earlier videos, where this question that we've been asking has started. And she says, "Greetings, student geologists. You did an excellent job understanding which processes formed the sediment and magma that ended up making rock formations in the Great Plains and Rocky Mountains. We now know the magma that formed the Rocky Mountains cooled underground. Use this new information to help you figure out more about the claims. How could the sediment that formed the Great Plains have come from the rock of the Rocky Mountains? How could the magma that formed the Rocky Mountains have come from the rock of the Great Plains?" So in our lessons a couple of weeks ago and our lesson yesterday, we looked at the different ways that energy can affect a rock. Energy from the sun is going to create sedimentary rock. Energy from inside the earth is going to create igneous rock. So what we're trying to figure out now is how could those two different rock formations have kind of met up? Where did the material for one come from? So we're going to look at our diagram here that she included. And our original question is, or our question that we're looking for now is, where did the magma and sediment that formed the rock of the Great Plains and the Rocky Mountains come from? Now, we have two possible answers. One is that the sediment that formed the Great Plains came from the Rocky Mountains, or the rock that makes up the Rocky Mountains. And claim two is that the magma that formed the Rocky Mountains came from the rock of the Great Plains. So we're going to try and figure out which one came first and how it was moved. Was it the sediment of the Great Plains moved to the Rocky Mountains, or the igneous rock of the Rocky Mountains moved to the Great Plains? You can look in the diagram to get a little bit more information and some hints actually about what could possibly be the answer. One of our questions asks, how is it possible that rock that is cooled underground move up to where it can be weathered? If we know that the Rocky Mountain is made of igneous rock, we know it was cooled underground. So how did it get to the surface of the earth where it could then be affected by the sun, go through weathering and erosion, and get to the Great Plains? That would be if we are looking for answer or claim number two. Claim number one would be, how could the sedimentary rock move down to where it can be melted? Because if we think the sediment of the Great Plains moved to the Rocky Mountains, that means it must have gotten melted by moving underneath the earth. So we're going to see how it's possible that cooled rock can move up and sedimentary rock can move down. Before we do that, I do want to quickly preview some of the type of work you'll be doing today. We haven't done this in class yet. We've mostly used Nearpod or Google Forms, but we are going to start using Google Docs every once in a while. And today's going to be the first day that we're doing that. So your work will be your own copy of your Google Doc. Myself or Mr. Love can go through this as we do it live so that we can see where you are in the work and make sure that you're completing it the way that you should be. However, I do want to go through just kind of like the norms and expectations when using these. First off, since you have your own copy, you can, of course, edit anything here. Like if I wanted to, click on this picture of text and get rid of it or accidentally get rid of it, that is very possible. So just be careful about what you are clicking on. Make sure you're not deleting anything that me or Mr. Love put into this Google Doc for you to work on. While you're working, it should be pretty clear most of the time where you should be typing. For example, if I see a table with a vocab word, obviously my definition is going to be going in this box right next to it. So anytime you see a blank box or maybe a box that has a sentence starter, such as down here, you're going to want to just click into that blank box or after that sentence starter and continue to type your answer in those boxes. You might also see some points where you have maybe a blank that you need to fill in. If that's the case, you could highlight that blank and get rid of it, or even just leave a couple lines of it, and then you could either fill in your answer here like that, or just completely get rid of that line and fill it in there. So anytime you see a line like a blank, that means that you're going to be filling in an answer there. You will probably have to get rid of that line, but that tells you where to actually work. While you're looking through your Google Doc and while we're doing the work together, also be aware of any links. For example, today's rock transformation simulation that you've used before is linked right here. So if you click on that, it'll bring up a link, and then you can click on that link to get into whatever website we need to go to or video we need to watch. So make sure that while you're using this, you're being really careful about where you're clicking, where you are deleting. It is just your copy. If you ever make any mistakes where you get rid of something you didn't want to, or you accidentally move something around, you can just use this little back arrow to undo it, or you can hold Control and hit Z, and that will undo You can keep going back to where you made your mistake, but just be really cognizant of what you are doing in this Google Doc. When you're done, you can submit it as your own assignment so that myself and Mr. Love can actually check off your work for the day. So what we're going to do next is actually go back to an article that we had previously read before. We did this in a Google form and we read it section by section and summarized each section. We're going to go back today and actually reread it and pull some really important information from it. So for the rest of your pre-work right now, you can stop this video and you can go to the link that says 3.1 Oldest Rock Formations article in your assignment, and you can read this on your own. If you would like, you can also just hang out in this video for a minute, and I will go ahead and after I give you a chance to leave, we'll do a quick read aloud if you feel more comfortable reading along with me. So if you feel comfortable reading it on your own, you can go ahead and stop the video now and go ahead to that article that's posted in your instructions. If you're still watching, we're going to do a quick read aloud of our article, The Oldest Rock Formations on Earth. I'm going to probably struggle with this name of the Greenstone Belt, so if I stutter a little bit, sorry about that. All right. The Nuva, ready? Here we go. Nuvu Agatuk. So the Nuvu Agatuk. The Nuvu Agatuk Greenstone Belt is a large group of rock formations located in Quebec, Canada. The Greenstone Belt is special, and it's one of the oldest groups of rock formations on Earth. In fact, the measurements show that the Nuva Agatuk Greenstone Belt is between 3.8 billion and 4.3 billion years old. That's almost as old as the Earth itself. When the Nuva Agatuk Greenstone Belt formed at Earth's surface, it was made of sedimentary and igneous rock. Now it is made of metamorphic rock. However, all the rock formations that make up the belt have stayed together ever since they formed billions of years ago. To understand how the rock in the Greenstone Belt could have transformed and how it could have stayed together as one group of rock formations, it is important to understand how rock material transforms and moves on Earth. Our next section is titled How Rock Can Change. It may seem like rocks never change, but the opposite is actually true. Over millions or billions of years, rocks are always in the process of being changed from one type of rock to another. Geologists classify rocks into three main types based on how they are formed. Rock that has formed from the cooling and hardening of liquid magma is called igneous rock. Rock that has formed through the compaction and cementation of sediment is called sedimentary rock. When a rock formation is exposed to heat or pressure deep underground, it becomes a third type of rock, metamorphic rock. Metamorphic processes transform rock without melting it. Plate movement and rock transformations. The Nuvu Agatuk Greenstone Belt is made up of metamorphic rock, so it must have been buried deep underground in the past. How can a giant rock formation like the Nuvu Agatuk Greenstone Belt move deep underground and then move back up to the surface? It's possible thanks to the processes of subduction and uplift. Earth's rocky outer layer is divided into plates. During subduction, one plate, along with all of its rock formations, moves under another plate and farther inside the Earth. When one plate moves under another plate, the rock formations move under Earth's outer layer to where energy inside Earth can transform the rock. In contrast, uplift is the process that pushes rock formations from down below up to Earth's surface. When one plate moves under another, the plate on top is pushed upward, which exposes it to weathering and erosion at the surface. The plate motion that causes both uplift and subduction is driven by energy inside the Earth. Because these processes are caused by enormous moving plates, entire regions of Earth's surface slowly subduct or are uplifted to form mountains. When this happens, the high pressure and heat caused by plate motion can change rock formations into metamorphic rock. These processes are usually very, very slow, but they never stop. Explaining the Nuvu Agatuk Greenstone Belt. Billions of years ago, the Nuvu Agatuk Greenstone Belt was made of sedimentary and igneous rock formations that were probably located near a plate boundary, where two plates meet. The Greenstone Belt experienced its last rock transformation 2.7 billion years ago when it was subducted and changed into metamorphic rock. These metamorphic rock formations were buried so deep inside the Earth that they were covered by many more layers of other rock. It took billions of years for the rock layers above the Greenstone Belt to be slowly weathered and eroded away by wind, ice, and water. Once the rocks on top were gone, the rocks of the Greenstone Belt were finally exposed. They had been transformed into metamorphic rock. Today, the Nuvu Agatuk Greenstone Belt has been weathered nearly flat, but is still made of the same rock formations that were formed so long ago. If you need to, you can go back and reread the full article using the link in the instructions. We will also read a small section together. If you're able to say the word Nubu Agatuk over and over without stuttering or messing it up, good job, and I'll see you in class.